Hello everyone. In today's video, let's try to solve a problem that is related to integer exponents. The source of today's video is from Canadian Open Mathematic Competition, problem of the week 2021, problem 2.13. Here comes the question. What's the minimum value of the absolute value of 12 to the x power minus y to the y's power, in which x and y both are positive integers? To find out the minimum value of this expression, we let m be this expression. First of all, we need to find out what values m could not possibly be. Since 12 and 5 are co-prime numbers, we can prove that m and 12 are co-prime numbers and m and 5 are co-prime numbers. If you know how to prove this, you can skip this part. Otherwise, let's assume that the greatest common divisor of m and 12 is a larger than 1. And from the expression of m, if we take the modulus a on both sides, it turns to a congruence expression. Since a is a divisor of both m and 12, and this congruence expression can be turned into 5 to the y's power is congruent with 0 modulo a. That means a is also a divisor of 5 to the y's power. However, this is in contradiction with the fact that 12 and 5 are co-prime numbers. From here, we can demonstrate that m and 12 are co-prime numbers, and in the same way, we can prove that 5 and m are co-prime numbers. So what does that mean if m and 12 are co-prime numbers and m and 5 are co-prime numbers? That means possible values of m include 1, 7, 11, 13, etc. And we know if x equals 1 and y equals 1, then 12 to the x power minus 5 to the y's power equals 7. That means the minimum value of m will be no more than 7. Then, now we need to check if it is possible that m equals 1, which means 12 to the x power minus 5 to the y's power, and its absolute value equals 1, which is equivalent to 12 to the x power minus 5 to the y's power equals plus minus 1. Remember, we have to consider both scenarios, 1 and minus 1. Scenario number 1, 12 to the x power minus 5 to the y's power equals 1. Similar to what we did before, we need to turn this equation into a congruence expression. But the question is, what modulus we are going to choose? We can choose 3, 4, 5, or 6, each of which will give you a different conclusion. Here, let's choose 4 as a try. Since 4 is a divisor of 12 and 5 divided by 4, the remainder is 1, then this expression can be changed into 0 to the x power minus 1 to the y's power, congruent with 1 modulo 4, which further changed to minus 1 is congruent with 1 modulo 4. Apparently, this is a contradiction, which means there is no solution in this scenario. Scenario number 2, 12 to the x power minus 5 to the y's power equals minus 1. Again, we need to turn this equation into a congruence expression. The modulus we're going to choose should be related to both 12 and 5. And this time, we're going to use 3. After a few steps, this congruence expression can be turned into minus 1 to the y's power is congruent with 1 modulo 3. And here, we can conclude that y is an even number. Since y is an even number, we let y be 2y0, in which y0 is a positive integer. And the original expression or equation can be rewritten as 12 to the x power minus 25 to the y0's power equals minus 1. Let's write down this equation here. To turn this equation into a congruence expression, the modulus that we're going to choose should be related to both 12 and 25. And this time, we're going to choose 13. The reason is both 12 and 25 are congruent with minus 1 modulo 13. And this congruence expression can be changed into minus 1 to the x power minus 1 to the y0's power is congruent with minus 1 modulo 13. If we take a look at the values on the left side, there are a few possibilities. If both x and y0 are odd numbers or even numbers, then the left side is equal to 0. If x is an even number but y0 is an odd number, then the left side equals 2. And if x is an odd number but y0 is an even number, then the left side is minus 2. That means possible values of the left side include 0 and plus minus 2. However, the right side is minus 1. Apparently, this is a contradiction, which means there's no solution in this scenario. So in summary, there is no solution for the absolute value of 12 to the x power minus 5 to the y's power equals 1. Then, therefore, the minimum value of this expression is 7. And this problem gets resolved. Thank you.